Okay, let's look at this example here. What they want us to do is they want us to compare f of x and g of x. Okay? So now, algebraically, what we need to do is, since it's over this interval, well, we want to see where these two graphs intersect, because they might intersect somewhere inside. Because remember, where they intersect is where they cross, right? So this function may be higher than this function, or this function may be higher than this function, but if they intersect, that means that they're switching. If f of x is up here and g of x is up here, and they intersect, then that means that now g of x is up here and f of x is down here. So we want to make sure we find the intersection points to see if anything's going on in this interval. Okay? So how do we do that? We set them equal to each other, right? So we're going to set g of x equal to f of x. Okay? And so we get the square root of 1 plus x is equal to the square root of 1 plus x squared. So now we square both sides, and we get 1 plus x is equal to 1 plus x squared. Okay? Which then gives us x is equal to x squared, which gives us x is equal to 1. Or no. What am I doing? This is going to give us x squared minus x is equal to 0, which then gives us x times x minus 1 is equal to 0. Okay, there you go. So now what happens? Well, these two functions intersect at x equals 0 and x equals 1. So they intersect right at the endpoints. Okay, awesome. That's actually, that's easy. Because now we know that 1 is on top and 1 is on the bottom through the entire interval from 0 to 1. So we just need to figure out which one is on top and which one's on the bottom. Okay, great. All we do is pick a test point inside 0 to 1, like a half, and plug them in. See which one is bigger. So if I plug in 1/2 here, I get 1/4. And I get 1 plus 1/4, right? So f of a half equals the square root of what? 1 1/4, which is 5/4. Okay? G of a half equals 1 1/2 Now, one 1/4 is obviously smaller than 1 1/2. So the square root of 1 1/4 is obviously going to be less than the square root of 1 1/2. So in this case here, g of x is greater than or equal to f of x on this interval. So g of x is greater than or equal to f of x over the closed interval 0, 1. So great, guess what? Now we can apply our comparison, one of the comparisons from the comparison theorem, that now tells us that, hey, since g of x is greater than or equal to f of x over this closed interval, then the integral from 0 to 1 of g of x dx has to be greater than or equal to the integral of f of x over the same interval. And that's the conclusion. Have a great day.